All right. So I ask you to work these problems out, 4 through 7. We're going to go over them really quick. And then I did put the notes for today in Canvas. Hope you were able to download that. And I'll tell you, we probably are going to be able to do 2 problems. The other 2 problems are going to be your homework, okay? And those 2 problems of homework that I already created the assignment for in Canvas are going to be problems 1 and 2. So that means that we are going to do problems 3 and 4, okay? So let's start with this then. 4, at what time does the object reverses direction? 1 second, let me grab my pen that fell.
Mr. Sanchez.
What's up?
An's saying he can't get in right now.
And?
Yeah, An's saying he can't get in.
Could you please tell him if he is in which Antran he's here?
No, Anjane.
Okay, William. Tell him to check if he has the correct code for the class. Tell him to check in Canvas.
Okay.
Okay, in one of the announcements. The announcement that I put at the beginning of the, okay, Anjane is here. Yeah, now I got it.
Oh, okay. Cool.
Okay. Now he's in. All right. Okay, so let's do these problems then, right? I asked you to work problems 4 through 7. So let's do this. Number 4, all right? It says, at what time does the object reverses direction? Find the position of the object at this instant. All right, so Miss what? Miss Sasha, such a good girl. What do you do for number 4? How do you do it?
Hold on. So I set the velocity to 0.
Okay, and what did you found?
I found t equals 2.
That is correct. So look, remember that the time is from 0. The time is from 0 up, right? Mm-hmm. So the velocity, and we did this before actually in problem 2 or 3, the velocity is 0 at 2. And the velocity is 2t minus 4, right? That's the equation of the velocity. 2t minus 4. So it is 0 when the time is 2. Okay, let me see, Jack. All right, so that means the following. Since this is a line, before 2, the velocity is negative. After 2, the velocity is positive, right? Mm-hmm. So that means that between 0 to 2 seconds, the object is moving to the left because the velocity is negative. And after 2 seconds, the object is moving to the right because the velocity is positive, right? So then 2 is the point where the particle reverses direction, okay? Because there is a change on the sign of the velocity. So the particle P reverses direction at t equals 2 seconds, right? All right, so then find the position of the object. We actually did that when we plug into the equation. And if we plug into, what did we get? Not everybody at the same time, because then my son.
-1.
0?
Nuh-uh.
-1 centimeters.
-1, right? So find the position of the object at this instant. So the particle, or P, is 1 centimeter to the left of the origin. Notice that we actually had all this information before, right? So it was a matter of making an interpretation of that information, okay? All right, so let's look at number 5. It says, draw a motion diagram of the object. So in this case, it's how the object is moving, all right? So let's try to do that. So again, the time starts from 0 up, right? So let's say this position here is the origin. The origin is when the time, well, I don't know what time is at the origin, but that's the origin. We'll see. We do know this according to what we did in the previous problems. Okay, William is here. All right. So when the time is 0, where is the particle? We found that to be 3 centimeters to the right of the origin, correct? And when the time is 2 seconds, so this is 3, this is time equals 2 seconds, the object is at -1, right? So that's the origin. That's when the time is 0 is 3, that's the position, the initial position. When the time is 2 is there. So what is the particle doing? So the particle starts here, right? And then in this amount of time, it moves up to that position. And we just found that when the time is 2, is reversing direction. So that means that when the time is 2, when the particle gets to be here, it reverses direction. It goes in the other direction. So we start here, moving in to the left, and then we get to -1, and then we reverse direction, and then we move to the right. So this will be the drawing for number 5, okay? For number 6, it says, for what time intervals is the speed of the object decreasing? If you go back and look at the definition, we need to find where the acceleration and the velocity have different signs. So let's redraw the diagrams that we have. So this is for number 6, okay? The velocity. The velocity, we just mentioned that is 0 when the time is 2 seconds, right? Before
Yeah.
we said that is negative, and after that we said that is positive. The acceleration, also we counted from 0, and we found that the acceleration is always positive, right? So if you look at these two diagrams, when do they have opposite signs?
At 2.
Only at 2?
Every value less than 2.
Right, so because they said the intervals, right?
Oh, okay.
So that means that they have opposite directions when the time is between 0 and 2. So this is when the particle is slowing down, or the velocity is smaller. Make sense?
Yeah.
When they have different signs. All right. So let's look at 7. 7 says, what is the total distance traveled in the time from 0 to 2 seconds? So look at the diagram. What was the distance covered between t equals 0 and t equals 2? The particle started here, and in 2 seconds, it moved all the way to where? To -1, right? So how can we find that distance? Well, in this case, it's very simple. Just count the units. What's the distance from 3 to -1?
4.
4.
4.
Oh, exactly. So what is the total distance? So total distance from time between 0 and 2 is 4, in this case, centimeters. Okay, so notice all we can do is count the units. Now I'm this is very simple because it's just between 0 and 2. I'm gonna give you an idea when you find a problem that might be a little bit more challenging. What happens if you have an object and it starts here at time 0, then is here at time 1, then is here at time 2, then is here at times 3, and then is here at time 4. How are we going to find the total distance? Okay, so it's similar in the sense that you're going to find the difference between where the particle is at time 0 with where the particle is at time 1. So you're going to find that first. Then you're going to add the distance from time 1 to time 2. So you're going to add this distance, right? So basically, this is D1, the first distance, this is D2. Then what do you do next? From time 2 to time 3. So you're going to find this distance from here to there. And that's going to be the third distance that you find. And then finally, you're going to find the distance from T3 all the way to what? T4. And then you're going to add all these distances. Make sense? In the problem that we just did, there was just one change that we did. So that's why we did it just one time. But if it's more than one, then you will have to do all this. Okay? Well, that was problems 4 to 7. All right? I want us to work a couple of problems from the notes of today. All right? And I just told you that your homework is problems 1 and 2. Just 2 problems for now. For now, so this is the first problem. First, we're gonna do problems 3 and 4. Okay? So I want to start with problem number 4. Okay, the last problem. Okay? So let's see. And the reason why is because it's a little bit different than what we have done up to this point. Okay? So Sasha, what are you doing?
Nothing.
You're not paying attention.
Nothing. It looks like you are either doing something else. All right. No? Okay. Number 4, right? It says the velocity in meters per second of a moving body is given by this function. So in this problem, they give us the velocity. 50 minus 10t. All right?
Yeah.
And they say find the acceleration. That part is simple. What's the relationship between the acceleration and the velocity?
Derivative.
Just the derivative. So just take the derivative of the velocity. This is a constant, so that derivative will be 0. And the derivative of negative 10t is just negative 10. Right? So the acceleration is negative 10 meters per second.
Negative 2.
Right? So it's always negative. All right, so that part was part A. Let's look at part B. Part B says the initial displacement S is 40 meters. Find an expression for S in terms of T. All right, so what makes this problem different is the following. Most of the time of the example that we have done, the position function has been given to us. And we were able to find the velocity by taking the derivative of the position and the acceleration by taking the second derivative of the position. But in this case, we are not given S. We're asked to find S. All right? So, what relationship there is between S and B? Because B is the one that is given to us. What's the relationship between the velocity and the position? Well, the velocity is the derivative of the position, right? Yes? No? So yes. What that means is the following. that we need to find out what should I take the derivative of in order to get the velocity. In other words,
Negative. Never mind.
just give me a second. What should we differentiate to get to this, right? So this is what we know. We know that when we take the derivative with respect to time of the position, we get the velocity. We get this, right? So they're asking, what is this? What's the function that we should have before we take the derivative? Any suggestions how we go about to do that?
Then you do the reverse.
Just the opposite. So you do like 50t minus 5t
And
squared.
then you do that it's plus 40.
Y plus 40.
Because that's the initial when t is 0.
Correct. So let's use that. So let's use what Cash and Soy said. S of 0 is 40. That's what it means the initial displacement is 40. When the time is 0, the particle is at 40 meters, okay? Now, Cash says that S of t should be equal to what, Cash? Can you repeat that, please?
50t minus 5t squared.
How do you figure that out?
I just
do the inverse.
the opposite.
You just did the opposite process, right?
Yeah.
You differentiate this, the derivative of 50t is 50, the derivative of negative 5t squared is negative 10. So S of t is gonna be equal to this plus the 40. Because if you plug in 0 here, what are you gonna get? 40, right? So then this is the solution for B. What we just did, Cash, do you know how the name of what we just did?
Oh, integration?
Integration, right? So this is the process, okay? So this is kind of an introduction to what's coming down the pipe. We take this function, the velocity, and we find the integral. Finding the integral means that we want to find the anti-derivative, which means what is before we actually take the derivative, okay? So when we integrate, we find the antiderivative. In this case, using the initial position, and what we just did together, the antiderivative is 50t minus 5t squared plus 40. You can organize this in order, like negative 5t squared plus 50t plus 40, okay? But that's what we just did. So when we move to the next section, that's what we're gonna be doing, integration or finding antiderivatives, okay? That's why I wanted to do this problem first, because it's obviously different than the others we've done. Any particular question? We're good, everybody? Yes?
Yeah.
All right. All right. So let's look at then at problem number 3, okay? Let's look at problem number 3. Problem number 3 says the displacement S meters at time t second is given by this function. So we have S of t equals 5 cosine of 3t plus t squared plus 10, and the time is greater or equal than 0, right? Okay, so part A says write down the minimum value of S. This is what I want you to see. It says write it down. It doesn't say find it, okay? So if I'm going to write it down, that implies that I should be able to read it or to see it. Make sense? So what I want you to do is put this function into your calculator. Make sure that the window is set so X is greater or equal than 0. And then let's find the minimum, because that's what it says. Write it down. So I need to find it. And and try to find out, okay? So go ahead and put your this equation into your calculator. Let me see. All right, so let me see why I'm gonna make it like 50 by 5, I guess, so I can see the whole thing. All right, this is what I'm getting, ladies and gentlemen. That is the function, okay? That's the equation, 5 cosine of 3x plus x squared plus 10. This is the window that I use. Sorry, that's the window that I use so I can see it, because initially I didn't see the whole thing. Okay. And then it should look like that. So the minimum is this point, right?
There are 3.
So let's find it. Second, calculate, or second trace minimum. Well, that minimum value is between 0, right? Because that will be 0, and somewhere to the right of this point. There. Enter, enter. And look, the minimum is going to be my y value, 6.049. So about 6.05. Okay. So part A will be just S min, right? The minimum of this position is about 6.05. Just because it says write it down, it doesn't say find it. So we don't have to take the derivative, set it to 0, so on and so forth. As a matter of fact, if we do that, we're going to find that derivative is 0 at 1, 2, 3, several points. Okay? That's why they want us just the minimum. Right? Tell me if you guys have any questions so far. Okay, cool. If there are no questions, let's then try part B, okay? Part B says, find the acceleration. So finding the acceleration will be to find the derivative of this, right? So, I'm sorry, find the second derivative, not the first derivative. So let's do that. So let's try to find the first derivative, which is the velocity, right? So the velocity is going to be, let's differentiate this first part. 5 is a constant, so we keep it. What's the derivative of cosine?
Negative sign.
Negative sign.
So negative sine of 3t times the derivative of 3t, because we need to use the chain rule. So times 3. That would be the derivative of the first part. Plus, what's the derivative of t squared?
T, 2t.
2t to the first power.
2t, and then the derivative of 10 is
0.
0. So my first derivative, right, s prime is negative 15 sine of 3t plus 2t. That's the velocity. Since I need acceleration, then I need the second derivative. I need the derivative of the velocity. So we need to differentiate this one more time. Okay. What's the derivative of sine?
Cosine.
Cosine. So it's going to be cosine of 3t times 15, if we do the same thing as before, right? So negative 15 cosine of 3t times 3. Same process as before. The 3 is because we have to use the chain rule, plus 2, which is the derivative of 2t.
Yeah.
So the acceleration then becomes negative 45 cosine of 3t plus 2. So that is the derivative, or the second derivative, that's the acceleration. Okay. Now, questions? We're good? Awesome. All right, so let's do C, because we have like 1 minute to do C. So this will be, let's do C. Find the value of t when the maximum value of A first occurs. So we want to find the maximum of this function, the acceleration, right? So we actually have to differentiate this one more time. Set it to 0 and solve, okay? So look, let's find the derivative of this thing. You know what the name of the derivative of the acceleration is? It's called jerk. Interesting name, but that's the name of the third derivative of a position, okay? So you can tell somebody, hey man, stop being such an A prime. They're not gonna know, but you're gonna know, okay? All right, so let's see. Find the derivative, right? The derivative of 2 is gonna be 0. So that's gone. So we're only interested in this piece. One more time. What derivative of cosine?
Negative sign
With this negative,
becomes positive.
so it's gonna be sine of 3t. The 45 is a constant, and we multiply that by 3 again. So at the end, we get what, 135?
Yes, 135 then.
Sine of 3t. We need to make this equal to 0 because we need to find the critical numbers, right? Which means that sine of 3t is equal to 0. Now, when is sine equal to 0? It's gonna be 0 at 0, right? But obviously that is not the position. That is not the max.
So pi.
Right? So it has to be here, right? Because the first time around that is 0. So what angle is this?
Pi.
Pi. So that means that 3t should be equal to pi. That's the angle that we need. Therefore, the time is pi thirds. Now, that is the value, that's the critical number, correct? That's the first critical number that makes this 0. How can I check if this is a max or a min? Second derivative test or first derivative test, right?
Or the
Sign chart?
yeah, sign chart.
Sign chart, right? But look, if you take one more time the derivative of this, right? Because now I need to differentiate this. That derivative is gonna be negative. Do you see why? Because the derivative of sine, well, actually no, the derivative of sine is what? Cosine, right? So cosine of 3t. That derivative is gonna be positive. Well, depends on the values of t. But what you need to do then is create the sign chart for this, which is simple. We just found that this is 0 at pi thirds, right? Look at what we're working with. If t is between 0 and pi halves, how is sine in the first quadrant?
Positive.
Positive, correct? So this is, and pi thirds is in the first quadrant, correct?
Yes.
So that means that pi thirds is what, 60, correct?
Yeah, 60 degrees.
So pi thirds is somewhere here. Before that, all this is positive. Yes?
Mm-hmm.
And then after that, that's gonna be negative.
Yeah.
So that means that pi thirds is gonna be a max there. Make sense? All right, kids. So sorry, I took like 2 minutes, 3 minutes over. But that's part C of number 3. Your mission, if you accept to take on the mission, actually you don't have a choice.
If you choose to accept.
Right, you have to accept it. Your mission is to do problems 1 and 2. All right, they're quite not that difficult. I think I want to do another part of kinematics so we can look at a little bit more complex problems, and then with that, we're gonna call it a day. All right. I mean,